Hi everyone, I'm sorry that I can't join you in person, but I still want to talk to you about how to root cause rebuilds with BB Explain. So Bazel has this great promise that it's fast and correct, and that usually holds true until it doesn't. We get lots of questions from our customers about why their Bazel build is surprisingly slow and why Bazel decided to rebuild so many targets when they just added a single file. Maybe they switched branches or they just came back from lunch and the Bazel server restarted. And then they ask, why is the remote cache rate so low? Well, why do build outputs differ when built on different machines? And these are all many questions you can ask about the Bazel build. And this comes down to two general problems or effects that you can have in your Bazel build, which is expected or unexpected, transitive invalidation, where a single change has a large transitive effect, or non-hermetic actions and outputs. And because this question is as old as time, Bazel has had the so-called execution log pretty much forever, since Bazel 0.14, which is a log file that you can enable that contains essentially all the processes that Bazel ran to serve your build or that it got from the cache. And for a very long time, the way to do this was to supply the execution log, JSON or binary file flag, and record this. That works, sort of. The problem is that even for the Bazel project, which is larger but not super large, this log is already over 1 GB in size. So in the Bazel 7 and Bazel 8 timeframe, Thiago set out to build a replacement for this that's much more efficient and can be enabled at all times. It's called a compact execution log, and you can enable it with -- execution log compact file. It's been stable since Bazel 8, and for the Bazel repo itself, it's less than 10 megabytes, which means that compared to the expanded log, you can now upload this to the BAS, which is done automatically. And it doesn't just allow you to recover the expanded log, it is actually more highly structured, as in preserves more of Bazel's inherent structure. So it gives you links between files and run files, and it also tracks symlinks. So it's actually more compact, but also contains more information than the expanded log. So what to do with it? We built BB Explain as a subcommand for our Bazel CLI, which allows you to determine the root causes of rebuilds by comparing two compact execution logs directly. So you can see changes in input files, environment variables, args, and even certain command line flags that cause widespread invalidation. It also detects non-hermetic differences between outputs and non-hermetic actions in general. It does not just tell you that something changed, it gives you the root cause, and it also computes statistics on the transitive effect of each such root cause. And it's pretty fast. It doesn't go through expanding the log to the expanded log and then diffing that somehow. It just diffs the compact representation directly. So it's pretty fast. For the Bazel build, Bazel repo itself, it takes less than 1 second on my machine. It's something like 200 milliseconds to diff and print all these root causes. How do you get it? Well, it's part of our CLI, which wraps Bazel and augments it with additional functionality. The CLI itself is MIT licensed, fully open source. You can grab the source from GitHub. If you want it convenient, you have the typical curl into bash thing, but you can also just build it with Bazel and then run it. It's easy to run. You just supply it with the path to 2 execution logs, and that just works. It's a static binary, static Go binary. You can just run it. You don't need anything else from BuildBuddy. If you do have a BuildBuddy account and you use our BAS backend, then you get some extra smarts. Like you can specify invocation IDs from which the execution log is then fetched, or you can just run just BB Explain without arguments, and that will automatically diff the last 2 builds that you did with BB. That's all nice, but as I said, it's not necessary. You can just download it and use it for its ultimate purpose. So let me show you one example of what this tool does. So as an example, let's take the Bazel repo itself again and add a private function to some low-level class. So that's an operation that we wouldn't expect to have many transitive effects, because ideally the way that Bazel builds Java, this would be stripped away and not affect any downstream actions. And if we do this, then this is the output from bb-explain on 2 such execution logs. And we can see that there was one root cause action which reran, which was the Bazel Java headed compiler turbine. And well, that had to rerun for a particular target because apparently we changed the content of the label.java file, which is pretty low level in Bazel's hierarchy. And of course, that had to rerun to regenerate the output, but it didn't cause any transitive invalidation because turbine just strips out private functions. And then we see that there was one more thing, which is that a regular Java compilation action reran for the same reason that input file changed. And that had some minor transitive effects because all of this stuff is bundled into the Bazel binary. There are some gen rules and a Java deploy jar action that collects everything on the class path. So see that there is some invalidation, but it's manageable. If you run the same thing on the same repo, but this time you add a public function, so you add something to the public API of the file, this has a lot of downstream effect because now this turbine action actually changes its output. And all downstream turbine actions and downstream Java compilation actions depend on this. So as you can see, the transitive invalidation count goes up, and this should immediately tell you that that was the root cause, and this is something that is worth looking into, and that potentially explains the reason for these rebuilds. There's also a way to detect non-hermeticity. So, well, the Bazel build isn't non-hermetic, so I had to conveniently forget to null out the timestamps in Bazel's release build, where it takes all the artifacts and, well, packages them into a zip file, conveniently now with preserved timestamps. I'm going to run 2 builds on my machine without with a clear cache every time. Then I run all this through bb-explain. And what I see is that the outputs of the action changed, but none of the recorded inputs did, which is pretty much by definition what non-hermeticity is. So this tells me that this file changed. It's sort of the first file in the graph that changed. It didn't have any transitive root causes itself. It changed. The action is provably non-hermetic. It invalidated something else. And now, if you use this with, well, either with any BAS backend or with a BuildBuddy BAS backend, then this tool will also give you the invocations that the execution logs were recorded from. You can open those. You can now download the outputs from the cache, as you would normally when you inspect action outputs, and then run the trusted and highly recommended tool diffoscope, which runs a bunch of different diff tools on the 2 files to report the relevant differences. So that's a major time saver when you do non-hermeticity searches. This tool will run essentially everything and give you very nice output, different points of view of how these files diffed. How does it work and why does it pass? So the first reason is that bb-explain is aggressively parallelized. It doesn't go through the expanded format, so it doesn't need to do a textual diff on a multi-gigabyte JSON file. All it has to do is to match up spawns, diff spawns being processes that Bazel runs. It can diff them. It can diff them all in parallel. It can parallelize decompression and parsing the compact execution log, which is secretly a ZSTD compressed protobuf file. And it can also parallelize the computation of transitive invalidations. And crucially, it's designed to have a runtime that is linear in the size of the diff that it outputs, not always quadratic in the input size. So if you get very small output, it's very fast. If you get lots of output, well, then hopefully that output was useful. And that's achieved by preserving depth sets that Bazel maintains internally, not expanding them eagerly, and instead computing shallow hashes at every level, at every depth set layer, comparing those first and only expanding depth sets if necessary, which precisely mimics what Bazel does. And the same trick is also used to track transitive invalidations. So yeah, give the tool a try. We hope that you find it useful. If you have any questions, find my colleagues at our booth or connect to me in Slack. Enjoy BazelCon.